Yes, question.
The domain must be a convex
Set.
that we don't need to explicitly check.
You have to check it. In this case, the function is defined over the entire real Rn, so it's already convex, right? But in general, your function may have a limited domain, so you would have to first check, because when I wrote down the definition of a convex function, point A was that the domain must be a convex set. So, for example, if I take this function which we tried to describe and I chose this domain over here, you don't even have to evaluate that convex combination. You can look at the set and say that this is not going to be a convex function. Okay. So, in this example, I assumed over here, you can, maybe I'll just write it over here, x and y, the entire Rn was where they lived. So, it's already convex, but you have to check it, you're right. Yeah.
Checking it for any 2 points, like, I think inductively you can prove for any convex.
In this case or in general?
No, if it's a convex function.
Yeah.
The statement which we had was that f of alpha x plus 1 minus alpha y should be less than or equal to, that linear combination.
Yeah.
Is it enough if we just take it for 2 points?
No, you have to prove it for all points in the domain.
No. What I mean is, like, is it true for any linear combination of 2 points? Like, let's say instead of alpha x plus 1 minus alpha y, we have sigma alpha x.
Correct.
You have to prove for that.
Yes, but okay, so he's asking a good question. Here I have taken the convex combination of 2 points x and y. Now he's saying, what if I take a convex combination of n points? Do I have to prove it for that also?
This proves that, but
Any thoughts on this? Is the question clear? I'm only showing it for convex combination of 2 points. The question is, but what about n points? Let's just, where should I write this? Okay. As long as?
The summation of the coefficients is 1.
Okay. The summation is going to be 1. He's saying it's a convex combination of n points. So, well, I can, supposing I have summation of alpha I xi, I can write this as x1 plus summation I is equal to 2 to n minus 1 alpha I xi from here, right. Now, is it true that, so I can take this as one new point, right, and this is another point, right. Now, all that remains to be proved is that the coefficients still satisfy the convex combination, and you will find that it does. So, 2 points is enough. Okay, it's a good point. Did everyone follow this? N points I can split as 1 and n minus 1, and it works for that and any combination like that. Okay. Again, we'll start with something very basic. Everyone is familiar about notation of a function, right? So, if I write f like this, what does it mean? It's a map from domain A to, what do we call it? We can call it codomain or range, right? So, this is the domain. What entity is it? Is it a function, a combination, a set? What is it? It's a set, right? Okay. So, just as we had, here are things, things get a little bit more broadened and generalized compared to what you studied in high school, okay. So, in high school, basically class 11, 12, you had a definition of continuity, which was quite straightforward. When we come to n-dimensional space, there are actually 3 different definitions of continuity that we have to talk about, okay. So, let's list those down. So, a function f is continuous at x that belongs to the domain of f, okay, if for all epsilon greater than 0, there exists a delta such that y belonging to domain of f, the distance between y minus x, obviously 2 norm, is less than delta, implies that So this is sounds like a complicated looking expression, but it's quite straightforward. It says that if you can find 2 points that are close by, then the function values that they map to also are close to each other. So that's our intuitive sense of continuity, right? That if I change x a little bit, the change in the f value is kind of, it's not exploding, it's bounded, right? But it's done in this formal language that for all epsilon greater than 0, there must be some delta such that this inequality is satisfied. So that means, the distance, the norm of y minus x simply refers to the distance between 2 points. So the distance between 2 points, x and y, if it's less than delta, I should be able to map it to a distance between the function values. Okay. So this is standard definition of a continuity. Okay. This is where you would have ended in your high school kind of course, right? Now things get a little bit more interesting. So now this constant that we are talking about, delta, okay, the constant delta, does it depend on epsilon, x and y? That is the distinction. Okay. In general, delta depends on epsilon, x and y. This is the most general case. Okay. And when this happens, we have called it continuous. But if delta depends only on epsilon, then this is another type of continuity. This is called uniformly continuous. Okay, I'll take an example in a few moments to clarify this. Okay, but at a high level, we follow what's going on, right? Does this constant depend on where I'm evaluating the inequality? Yes or no? Yes, it's continuous. No, I'm saying I'm making a stronger statement. I'm calling it uniformly continuous. Okay, and so let's call this B. Okay, and finally, C is something which we will also use quite a bit in the course, which is called Lipschitz continuity. Okay, so the function f so I'm going to take this distance fx minus fy, okay, is bounded by some constant L times the distance between x and y, okay, for all x and y belonging to the domain of f. Okay. So notice the slight difference in flavor with definition A or definition B. In the definition A or definition B, the distance between the function values was just related to a constant epsilon. But here what are we saying? This distance is sort of proportional to the distance between the points x and y. Notice norm of x minus y is appearing on the right hand side here. It did not appear earlier, right? So this is a difference, and this is called Lipschitz continuity. So why are we talking about these three different types of continuity, right? The thing is that if you're interested in going into analysis of optimization algorithms and trying to prove rates of convergence, these properties become important. If you're only interested in implementing an algorithm and getting your results and are happy to take someone else's report that this has superlinear convergence, this has quadratic convergence, you need not bother about this. Okay. Yes, question. L is just a scalar, finite scalar. Yeah. Yeah. Finite positive number. Okay. Yeah.
I can't figure out the difference between B and C. It just feels like there's a relation between delta and epsilon, and if I divide like that delta by epsilon by delta, I'm getting L.
It's not quite the same, right? you're saying that if I divide, you'll get something like epsilon by delta over there, right? The trouble is that this epsilon and, for example, delta can depend on x and y, right? Then your constant of proportionality will become a function of x and y. But here we are saying that it is a positive quantity. So actually, to clarify this, let's take a concrete example and we'll show you where a function is b but not c, or some combination of that. That would clarify it. Just looking at the definition is a little confusing, I agree. So let's take an example. Let's take f of x square root 1 minus x square, and to keep life in the real world, I should restrict x to where? Minus 1 to 1. Okay, this guarantees that f maps from minus 1, 1 to r, otherwise I would get complex numbers. Okay, and now we want to figure out what type of continuity this function satisfies. Now, root of 1 minus x square, intuitively, if you graph it, for example, it looks like a continuous function. But which precise type of continuity does it satisfy is something that we want to see. Okay. So, the usual procedure in all of this is take 2 points and take their difference and the difference of their function values, and then see what happens, which way do the inequalities follow, right. So, I am going to take x and y as 2 points that belong to minus 1, 1. Okay. I am going to choose, let's say that these 2 points are delta close, okay. And now we have to see what does this translate into the difference of f, okay. So now consider notice that this problem is really simplified in the sense that all the norms are replaced by absolute values, because we are not dealing with any vectors over here. These are scalars, just to get the idea. So, when I write down this norm of mod of fx minus fy, I am going to get something that looks like this: 1 minus x squared minus 1 minus y squared, right? Which does not look like something I can make much traction with, right? I have the difference of 2 square roots and it's a little tedious to proceed further. Standard trick is square it, right? Because we are dealing with positive numbers, if you square it, you are still, you can trace back. So, let's consider square of this, okay. Now, when I consider square of this, immediately what I can do is, I can write this as 2 terms, right. I can say 1 minus x square, 1 minus y square, and the same thing again, 1 minus x square minus 1 minus y square, okay. Now, would you agree that these quantities, root of 1 minus x square is a positive quantity, root of 1 minus y square is a positive quantity? Can anyone suggest some way forward? This is mod a minus b multiplied by mod a minus b, that's a hint. If I were to make one of these into mod a plus b, would that help me? It would help me, right? So, can I do that? So, supposing I call this guy a and I call this guy b. Something simpler? Okay, what do you think about this? Fill in the blank. Less than or equal to, right? It's the difference of 2 positive numbers is going to be less than the sum, right? So, I can put this over here. So, what happens over here then? So, currently I have equality, right? Then this expression should be less than or equal to or greater than equal to. I am going to use this inequality over here, less than equal to. I am going to replace this by, this remains over here, 1 minus x squared minus 1 minus y squared, right? And this becomes root of 1 minus x squared plus 1 minus y squared, right? So what's next then? What does this become? A square minus b squared. The mod still has to be there because the overall thing is a positive quantity. So this becomes less than, or in fact this becomes, I should not write this, this becomes equal to root of a square minus b square, which is going to be what? 1 minus x squared minus 1 minus y square. What do I get? X square minus y square, right? Anything else that I can do? Correct. So this x square minus y square can again be written as, right? Now can I bound this further? X plus y has to be less than or equal to 2. So this becomes less than equal to 2 times mod x minus y, right? So you got the trick that we were trying to do. We started with mod of f minus fx minus fy, and in order to get to these continuity definitions, I needed to get mod x minus y on the right hand side by hook or crook. So these kind of simple inequalities have now gotten this term over here, right? So now this mod x minus y is what? What did we assume it to be? Less than delta. So this becomes 2 delta, okay? So, and remember this was mod of fx minus fy squared. So implies that mod of fx minus fy is less than equal to root of 2 delta. Perfect. So this is my epsilon. So what did I do? I started with 2 points x and y that were delta apart. I was able to show that I can come up with an epsilon such that f of x minus f of y mod is less than or equal to epsilon, right? And is this true for all x and y, or for, does this expression, I mean it's obvious, it's just 2 delta, there is no x or y appearing over there. So this is true for, I mean it's, of course it's true for all x and y, but my epsilon, does it depend on x and y? No, it only depends on delta. So what kind of continuity is this? This is uniform continuous, right? Okay. I mean, you can see the algebra over here. When you look at it at first, it seems like a little bit of magic. How do we land up with this? But you know that once you get the hang of it, the idea is somehow to get mod x minus y on the right hand side. So then you can see a few simple inequalities gets us to this, right? And there are just a few standard tricks in the book for doing this. So with practice, you get good at it. Then you get greedy. You say, okay, it's uniformly continuous. Maybe it's also Lipschitz continuous. So that's the next question. Is it Lipschitz?